Welcome back, students. Continuing with the preparation of alcohol. In the last class, we have seen the preparation of alcohol by reduction of carboxylic acid and esters. Now, moving further, and let's see the next method for the preparation of alcohols. In the next method for the preparation of alcohols, we are going to see the preparation of alcohol from Grignard's reagent. Grignard's reagent. In the haloalkanes chapter, we have studied about this Grignard's reagent. The Grignard reagent is nothing other than RMgX. Okay, RMgX. And the property of the Grignard reagent is that it always break in the form of carboanion, okay, and magnesium halide cation. It always break in the form of carboanion and magnesium halide cation. And here the reason is that due to presence of covalent bond between the alkyl group and the magnesium here, as magnesium is having more positive charge and due to high electronegativity of the halides, the electrons of the magnesium is attracted towards the halogens here, and due to this reason the positive charge, the electropositivity of magnesium increases out there, which helps to break this bond, the covalent bond between the alkyl group and the magnesium here, and hence carboanion is being formed in with the magnesium here, which is having the positive charge here. Okay, so try to remember this thing always, that here always a alkyl carboanion will be formed out. Now what happens in the reaction here? Here if I am taking a carbonyl compound, okay, if I am taking a carbonyl compound, the carbonyl compound will be C double bond O with two bonds open for it. So these are the carbonyl compounds in which a carbon is attached to the oxygen with a double bond. And generally this type of compounds are aldehydes or ketones or esters. Okay, these three types of compound can be react with Grignard reagent to give the alcohols here. Now, when it is reacted with the Grignard reagent, okay, the Grignard reagent is RMgX. So here the carboanion and magnesium will be in the positive charge. So this carboanion will attack, which is behaving as a nucleophile, okay, which is behaving as a nucleophile. It will attack the positive part of the carbonyl compound, that is the carbon here. Okay, it will attack the carbon there, and the positive part of the mgx, the positive part of the mgx will attract towards the negative part of this carbonyl compound, and in the presence of dry ether they will form a addition compound. They will form a addition compound. Now on hydrolysis of this addition compound, on the hydrolysis of this addition compound, here this particular MgXO, it will get attached to with this O. Okay, means the hydrogenation of this MgOX will be taken place, and it will form MgOHX, and the alcohol will be formed out here. Okay, alcohol will be formed out here, that is C. R will get attached here and OH will be formed out. So the H is attached to this O here, and the MgX is attached to the OH from the water here. It is forming magnesium hydroxide halide. Okay, magnesium hydroxy magnesium halide, hydroxy magnesium halide, and this is the alcohol which we require. So this is the mechanism for the reaction here for the preparation of alcohol from using Grignard reagent. So first, let's take an example for the aldehydes. So formaldehyde, first example we are taking here for formaldehyde, which will give primary alcohol. Okay, it will produce primary alcohol when reacted with Grignard reagent. So I am taking formaldehyde HCHO. It will react with Grignard reagent, that is CS3 MgBr, in the presence of dry ether. In the presence of dry ether, here the addition compound will be formed, and on hydrolysis of this addition compound, the alcohol and the alcohol and MgOH Br will be formed out. Okay, this alcohol is nothing other than the ethanol, 1 degree alcohol, ethanol, which is a primary alcohol. Similarly, if you are taking another example, that is any other aldehyde other than all aldehydes, other than formaldehyde will give 2 degree alcohol. Means they will produce secondary alcohol, except the formaldehyde. Formaldehyde is the exceptional case where it will produce 1 degree alcohol. Either all the aldehydes, other aldehydes will produce 2 degree aldehydes. Okay. For example, I am taking acid aldehyde here, CS3CHO, ethanol or acid aldehyde. Okay. So here, when it is reacted with Grignard reagent in the presence of dry ether, it will produce an addition compound. Then on the hydrolysis of this addition compound, alcohol, that is secondary alcohol, plus MgOH Br will be found out. This is the secondary alcohol, that is propane to all, which is a secondary alcohol. Okay, so all other aldehydes other than formaldehyde will give what? They will produce the propane to all, that is the secondary alcohols. Next is the ketones. Ketones gives 3 degree alcohols. Okay, ketones on reaction with the Grignard reagent will produce 3 degree alcohol. So taking example here, acetone or propanone. Okay, so acetone or propanone will produce a tertiary or 3 degree alcohol with the Grignard reagent, CS3 MgBr, in the presence of dry ether. It will give CS3 CCS3 CCS3 OMGBr, which is the additional compound here, Then this addition compound will on hydrolysis will produce alcohol, and that alcohol will be a tertiary alcohol. It will be a tertiary alcohol, and MgOH Br will also be produced. Okay. This is the tertiary alcohol, that is 2-methyl propane 2 all, 2-methyl propane 2 all, okay, which is a tertiary alcohol. Next is the reaction of ester, okay, reaction of ester with Grignard reagent. So ester gives 2-degree and 3-degree alcohols. When reacted with Grignard reagent, they will produce 2-degree and 3-degree alcohols. Ester can also be converted into alcohol by treating with suitable Grignard reagent. Secondary alcohol can be prepared by addition of suitable Grignard reagent to ester of formic acid, while followed by the acid hydrolysis. For example, here we can take an ester COHOC2H5. This is the ester of formic acid, okay, that is ethyl methanoate. This is ethyl methanoate or ethyl formate. Ethyl formate. Okay. So this ethyl formate, when reacted with suitable Grignard reagent. So here suitable Grignard reagent will be CS3MgBr in the presence of dry ether. They will form an additional compound, that is COMgBr, OC2H5, and CS3 will attach here at the bottom. This is the addition compound. The reaction will further be proceeded, and here we will see that the MgOC2H5Br will be released out here, and the compound which is left out here, it will be C double bond O CS3, that is acid aldehyde. So here first we have converted the esters into acetaldehyde, that is aldehyde. Now again here the reaction between the aldehyde and the Grignard reagent will take place in the presence of dry ether, and here we will produce what? Here we will produce the additional compound, and on hydrolysis of this addition compound, on the hydrolysis of this addition compound, we will release out here MgOHBr, and alcohol will be formed out, which will be the secondary alcohol. Okay, secondary alcohol will be formed out, isopropyl alcohol, isopropyl alcohol. Okay, so this is the method for reaction of production of alcohols from the Grignard reagents reaction. Next, by hydrolysis of ester also we can produce the next type of reaction, where we are going to see the hydrolysis by the hydrolysis of the esters. Okay, means the number 5, hydrolysis of esters. So here for the hydrolysis of ester, the general reaction will become the ester, that is RCOR dash, plus they will be hydrolyzed with sodium hydroxide in the presence of sodium hydroxide. Okay, generally the alcohols are generally prepared by hydrolysis of ester with aqueous alkynes. Okay, with aqueous alkyne, if they are reacted, then they form alcohols. So here the reaction will take place, and the hydroxide from the alkali, okay, aqueous alkali, will react with the alkyl group of the ester to form sodium salt of acid. Okay, sodium salt of acid, also alcohol. It will form sodium salt of acid. We can take example here, CS3, C double bond O, O, C2H5 plus NaOH in aqueous solution. So in the aqueous solution here, it will produce sodium salt of carboxylic acid, that is sodium acetate, sodium acetate plus ethanol. Ethanol will be found out here. Next, preparation of alcohols from alkenes. Preparation of alcohols from alkenes. So alkenes can be prepared, the alcohols can be prepared by alkenes, and in this the first method is by the acid catalyzed by acid catalyzed hydration of alkenes. Acid catalyzed hydration of alkenes. Okay, so hydration of alkenes can be carried out directly or indirectly. Hydration of alkenes, that is addition of hydrogen to alkenes, can be carried out directly or indirectly. Okay, it can be carried out directly or indirectly. In the indirect process, first let's see the indirect process. In the indirect process, alkenes are passed through concentrated H2SO4. Okay, alkenes are passed through concentrated H2SO4 to form alkyl hydrogen sulfates, which upon hydrolysis with boiling water gives alcohol. Okay, so here when alkenes are reacted with H2SO4, okay, so I am writing SO4 in this way, which is concentrated, and on reacting it with alkene, it will form CS3, CH2, OSO2, OH, H2O with boiling water. So it will form CS3, CH2OH plus H2SO4 again. Okay. But in the case of symmetrical alkenes, the addition of H2SO4 takes place in the accordance with Markovnikov rule. Okay. That is, in the case of unsymmetrical alkenes, what will happen? Here, we will follow the Markovnikov rule. It means that if I am taking an example here, propene. Okay, in case of propene, when we are reacting it with sulfuric acid, then Markovnikov rules, according to the Markovnikov's rule, the compound formation here will be CS3O SO2OH. Then with boiling water it will produce CH3, CH, CH3, that is propane 2 all, and sulfuric acid will again be released out there. Okay, so this is the method to prepare, and here you can see that the OH is been attached to the carbon atom which is having low number of hydrogen, and the H is attached to the carbon atom which is having higher number of hydrogen there. Okay, so this is the method in order to prepare the um, alcohol from alkenes, where Markovnikov rule is been followed out. Now next is the method of preparation of alkenes by anti-Markovnikov rule. Okay, by anti-Markovnikov rule. This is also termed as hydroboration oxidation reaction. Hydroboration oxidation reduction. Hydroboration oxidation reduction. Hydroboration oxidation reduction. So here alkenes reacting with diborane, okay, B2H6, to form trialkyl boranes, which upon subsequent treatment with alkynes will produce in the presence of will produce H2O2. In the presence of H2O2, that is hydrogen peroxide, will give alcohols. And here the combination of the joining of the OH and the H ion here will be on the basis of the anti-Markovnikov rule. Okay, it will be on the basis of the anti-Markovnikov rule. So let's understand this reaction with an example here. So I am taking example of propene. Propene on reaction with borane in the presence of tetrahydrofuran, hydroboration will take place, and an intermediate compound, that is tripropyl borane, will be formed out here. Tripropyl borane. Tripropyl borane is formed out here, and with the action of hydrogen peroxide we will produce an alcohol, that is propane 1 all. Propane 1 all. Okay, so here the addition of the alcohol, okay, OH group is done in the basis of the anti-Markovnikov rule. Okay, on the basis of the anti-Markovnikov rule it has been placed out here, and hence it is just opposite to the previous reaction which we have studied. There Markovnikov rule was acting, and here anti-Markovnikov rule is acting, because due to the presence of this hydroxide, hydrogen peroxide. Next is the formation or preparation of alcohols from preparation of alcohols from next is the preparation of alcohols from aliphatic primary amines. Aliphatic primary amines. So primary amines, when reacted with nitrous acid, okay, and nitrous acid is prepared readily with the reaction of sodium nitrate with sodium nitrous with hydrogen chloric acid, okay, that is HCl. So here nitrous acid is been produced. So here HONO, that is nitrous acid, when reacted with the amines, 1 degree amines, then here reaction will take place. and N2 formation will take place here. Okay, N2 formation will take place, and the left out compound will attach with each other. That is, the formation here, it will be RCH2 OH plus N2, and H2O will be formed out. Okay, here you can see that H2O is joining with each other, N2 is joining with other nitrogen, is joining with other nitrogen, and this OH is joining with the RCH2. Okay, forming a 1 degree alcohol. That is, a primary alcohol will be formed out here. Taking an example here, CH3, CH2, NH2, HONO, and here nitrous acid is formed by NaNO2 plus HCl. It will give CH3, CH2OH, that is ethanol, with dinitrogen and with water. Next is the industrial preparation for alcohol. Industrial method of preparation. So in this industrial method of preparation, the first method is the hydration of alkenes, which we have studied previous also by the direct method and the indirect method. That is the one method which is generally used. Next is the OXO process. OXO process. In OXO process, alkenes are reacted with carbon monoxide and hydrogen in the presence of cobalt carbonyl as a catalyst there, and at very high temperature and pressure they will give aldehydes. Now, after doing the reduction of this aldehydes, that is hydrogenation of this aldehyde in the presence of catalyst, we can prepare alcohol. Okay, so the reaction will be alkenes reacted with carbon monoxide, and hydrogenation is been done out here in the presence of cobalt carbonyl as catalyst here at very high temperature and high pressure. At very high temperature and high pressure, it will form aldehyde. Here it is propanol. Now, on further reduction of this propanol in the presence of catalyst, catalytic hydrogenation will be done. Okay, catalytic reduction will be done here, hydrogenation will be done to produce alcohol, that is CH3, CH2, CH2, OH, propane 1 all. Okay, so this is the OXO method. Next is the fermentation method. Fermentation method of the carbohydrate. So in that, the fermentation of the carbohydrate is taken place with the enzymes. Okay, in the presence of biological enzymes, where the ethanol is been produced out there. So here in that method, in the fermentation of carbohydrate method, the A process is the ethanol production from sugar solution, that is molasses. Okay, after the formation of sugar crystals, the leftover which has been present out there, okay, which is containing enough amount of glucose in it or sugar in it, it is termed as molasses. Okay, so molasses, which is not the crystalline form of sugar, it is been diluted to 10%. It is very thick. Okay, it is very thick. So that molasses has been diluted to first 10%, and then yeast is added to that. Okay, yeast is added to that solution, and it is left for 2-3 days. The yeast there, using the invertase and zymase, they will produce the alcohol there. Okay, they will produce the alcohol there to convert the sugar into alcohol. So the proper reaction which is taking place here, it is C12H22O11, which is sucrose, the sugar present in the molasses. In the presence of water, here the invertase, a biological enzyme, okay, it will break this sucrose into into fructose and glucose, that is C6H12O12 O6. This will be glucose and fructose, that is C6H12O6, that is fructose. Now either this glucose or fructose, it is been converted to alcohol by the action of zymase, the another biological enzyme, okay, zymase, into alcohol C2H5OH, that is ethanol, and carbon dioxide will be released out. So this is one of the industrial method to prepare the alcohol by fermentation method. The second method is the preparation of ethanol by starch. Ethanol from starch. So ethanol is also prepared industrially by starch substance such as potato, barley, yam, etc. So starchy substances are made into a paste. First, the potato or the yam or the barley, etc., are converted into paste first, and then it is heated, superheated to 335 Kelvin, and a malt is been added. This malt is containing the enzyme, that is diastase. Okay, this diastase converts the starch into maltose. Then this maltose is converted to glucose, and the glucose is then converted to ethanol. So here the starch, which is none other than the polymeric form of the glucose, it is more large sugar, okay, large sugar, which is called as starch. It is first broken into maltose by diastase, okay, and biological enzyme diastase. It breaks it breaks the starch into maltose. Now at about 305 Kelvin, yeast is added to this maltose. We will add yeast to this maltose, okay. On adding yeast here, the maltose will convert to glucose here in the presence of maltase enzyme, okay. In the presence of maltase enzyme, this maltose will convert into glucose, and further this glucose, in the presence of zymase yeast, okay, in the presence of zymase from the yeast, zymase enzyme from the yeast will be converted to alcohol, that is ethanol, with carbon dioxide. So this is the preparation of industrial preparation of the alcohols by fermentation. So for today, I am ending the class here only. We have completed the preparation methods of the alcohols. In the next class, we will see the preparation method for the phenols. Okay. So today I am closing the class here only. Thank you.